Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to call in and participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You are always welcome to join me through the Zoom platform. The Zoom link is available from me, your teacher, and also your DEC. Our classes are scheduled on Monday through Thursday, 11 till 12 in the morning, and we now are starting our 5th week of our 9-week course. To know what work to submit for marking, first support questions in your booklets are the ones marked with the pencil icon, and they are not for marking. These are just for your own practice, so you decide which ones and how many to do. If you're understanding a concept, feel free to skip questions. If you need more practice, let me know and I can send you more. The answers are in the back of your booklet, so check your work to make sure you're on the right track. However, mistakes have been found, so if anything isn't lining up for you, let me know and we can check to see if that's a mistake. The key questions, those marked with a key icon, are the marked questions. So please do all of them and show all of your work, your steps, and your thinking. This way I can give you credit for all of your understanding. And if you make an error, you don't lose all the marks, you just lose the marks for the error that you made. To submit your work for marking, there are 3 methods. The first method is to scan your work and send it in electronically. So scan your completed work through either the iPhone's Notes app or your Android Google Drive app if you have a smartphone. If you don't and you just want to take pictures, that's fine too. Then send it to me through either email at studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the big red building next to the post office, and there's a small white mailbox at our side entrance. It may take me a couple of days to pick it up as we continue to work remotely, but once I get it, I'll get it back to you as soon as I can. Our third method is to hand it into your DEC. The DEC can then send your work through the Express or fax it to 807-737-1732 or through toll-free fax 1-800-463-7852. Always, if you have any questions or concerns, please contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can also connect with me through Facebook at bslatewahsa. You can call and leave a message for me at the main office and I can call you back. The number there is 807-737-1488, or you can call toll free 1-800-667-3703. My current office hours are Monday through Friday, 8 a.m. to 2 p.m. and I'll get back to you as soon as I can. If you'd like to connect with me through social media, my Facebook and YouTube channel are both called bslatewahsa. So please friend me on Facebook or subscribe to my YouTube channel. All of our radio Zoom classes are posted shortly after airing on YouTube, and I share them on Facebook, so you can access replays of the videos and the lessons. There's also short videos explaining common errors and confusing concepts on my YouTube video or my YouTube channel, so that's a great place to check if you're struggling with an idea. I have supports there. Math is a very visual subject, so being able to access the videos is really important. It's going to set you up for the most success. So either joining me through the live Zoom lessons or watching the replays on YouTube is really going to make things make the most sense. So please try to connect there. If you don't have access to the internet or it's spotty, but you do have access to a computer, let me know and I can send you the recordings on a USB key. All right, we're on day 16 of our course. We're almost halfway through. And today we're looking at lesson 11. We're starting unit 3, and this is trigonometric ratios. So our learning goals are such that at the end of this lesson, 1, you can say, I will be able to recognize and label parts of a right triangle. And 2, I will understand how to use trigonometric ratios to find unknown sides and interior angles of right triangles. Our success criteria, you know that you've met your learning goals because you can say, 1, I can identify the opposite and adjacent sides as well as the hypotenuse side. 2, I can solve for unknown sides using trig ratios. And 3, I can solve for unknown angles using trig ratios. We're not going to get to the third, to solving unknown angles today. It's just too much to fit into one day. So we're going to work on those in our next lesson. All right, let's activate our brains and do some mental math. We all remember mad minutes from when we were in elementary school. They were a negative experience. Many of us just caused anxiety and stress instead of actually helping us learn our math facts. So instead of focusing on memorization, we work on developing strategies that help to do arithmetic that we can apply in different situations and help us get more comfortable with numbers. So today we're going to be looking at, our question is 115 plus 293. And we're going to add these together by breaking up the numbers into place value. So often with the algorithm, we're told to stack our numbers and start at the ones and then carry and go ones, tens, hundreds. I'm actually going to do this the way that we're told not to and do it logically, what makes sense to me. So 115 plus 293, I'm going to say, well, 100 plus 200 is 300. Okay, I can hold that in my head. And then I'm going to say, okay, well, 10 plus 90 is another 100. So 400 in total. I got that in my head. I have 5 plus 3. That's 8. So 8 plus 400 is 408. So 115 plus 293 is 408. And that's a strategy you can use. Doesn't matter how big or small your numbers are. It can be really useful. You just need to keep track to make sure that you're using place value properly and that you're remembering that 115 is 100 plus 10 plus 5. Okay, mine's on. Let's engage in some prior learning and remember some skills that we need for today's lesson. We're looking at triangles in trigonometry. At this level, we're looking at various things we can do with triangles. So we need to make sure that we know what a right angle triangle is. And it means that one of our angles in our triangle is 90 degrees. A right angle is defined as a 90-degree angle. And the symbol that we use when we're drawing that is a little square. It looks like it makes a square in our corner because a square has 90-degree angles in all of its four corners. So it doesn't matter which way your triangle is oriented. Triangles are just three-sided objects with three corners, three vertices. And one of those corners, one of those sets of angles, if it's got this symbol in it, this 90-degree symbol in it, then it's a 90-degree triangle. A right triangle is what we call it. If we have a triangle that does not have that symbol, does not have the little square symbol in one of the corners, we cannot assume, even if it looks like it's 90 degrees, we cannot assume that it's 9 degrees. So if there's no right angle symbol, it means that it is not a right angle. So we cannot, even if it looks like it is going to be a right angle, if there's no symbol, we can't assume that it is. That's really, really important. We have to use the symbols. Right, we also need to know what proportions and ratios are. So this is a little bit of a reminder. So being a proportion means that two ratios or fractions are of equal value. Commonly, a ratio is a comparison of two values of the same kind. So we have a part-to-part ratio, compares the number of parts of a whole to the other parts in the whole. We have a part-to-whole ratio, compares the number of parts of a whole to the total of all parts in the whole. And a ratio could have more than two terms. So we're going to be using ratios throughout these lessons. And so it's important to be comfortable with the fact that they're meaning that ratios mean that the two terms or more terms are of equal amount. So for example, I have 1 over 2 equals x over 50. Because they're equal, these are ratios. So we are saying 1/2 equals something over 50, how much is that something? So that in this case, X would equal 25 because 25 over 50 is equal to 1/2, is equal to 1/2. So then I also have my next ratio is 1/3 equals 65 over Y. So again, this is a ratio telling me that 1/3 is equal to 65 over something. So I can think, okay, well, I needed to do, in order to go from, to get this ratio to be the same, I've increased 1 times 65 to get to 65. So 3 times 65 is going to be what? So 3 times 65 is 3 times 60 is 180. 3 times 5 is 15. So that's going to be 195. So Y would equal 195 in order for these two fractions to be the same, in order for that ratio to be true. And then I also could have, this example is 4/5 equals A over 25 equals 32 over B. So here I have multiple fractions equaling each other, but because they're all equaling each other, we can use that information to help us. So in order to get from 5 to 25, I times that by 5. So I want that to, my 4 to move in the same proportion, in the same relationship. So if I times it by 5, that means that A is equal to 20, because 20 over 25 is equal to the same thing as 4/5. They're the same ratio, the same relationship. And also I can say, okay, well, if I have 4 times what gives me 32? Well, 4 times 8. So I have 8 groups of 4, increases this by to get 32. So then I have 5 times 8 to keep my relationship the same. So B is going to equal 40. I like to think about this if it's kind of like if you're making juice and you have 4 parts out of the total of 5 is water. So if you're increasing your amount for a party, then you have to increase both the amounts of water that you're making and the total amount that you're going to get. That could be one way to think about it, or however you're thinking about it in terms of like groups like that you're increasing for a party or something, helps you think about that you want to keep the same ratio so that everybody gets the same amount, or the flavor is the same. That's what proportions ratios are. So we're going to use that throughout. All right, let's dive into our new concepts. As always, when will I use this in real life? So we are strengthening our comfort with numbers. This can get a little bit confusing, but we're getting more comfortable with numbers because that's always going to set us up for success. Trigonometry is all around us. It's in surveying, it's in construction, it's in forensics with like blood splatter patterns. It's in video game design as well as playing video games. It's in navigation and satellite movements in terms of like when you hear about triangulation, about cell towers and things like that, that's all trigonometry. So this is really important to know what we're doing. So trigonomic ratios are the ratios of any two sides of a right angle triangle in terms of the reference angle. So sine, cosine, and tangent ratios can be used to find unknown sides and angles. So in order to understand sort of what we're doing, we want to think about scaling an object. So here on the screen, I have our Wahsa's logo. And it's important that if I zoom in and that gets bigger, everything stays in proportion. It doesn't get skewed. It doesn't look any stranger. It looks in the same relationship. Same thing as if I shrink it and it gets really small. Again, it's smaller, but I'm still seeing the exact same image. It's just like it's a smaller image. And that's what we're doing with scaling an object. And that's sort of what we're talking about with triangles. So it doesn't matter how we zoom in or zoom out. We're looking at the exact same image, and the angles and the lengths are all in proportion. So with our triangles, I have a triangle with side A, B, and C. That's a right angle triangle. We have 58 degrees in one corner and the other angle is 32 degrees. So if I were to zoom in and make that, or zoom out and make that smaller, I still would have, my angles would still be the same, 58 degrees, 32 degrees, and 90 degrees. And my sides now are going to be smaller, but they're still going to be in the same proportion to each other. They're still going to be the same relationship. The same thing as if I zoom in and make my triangle bigger, my angles stay the same, 58, 32 degrees, and 90 degrees. And my sides now are longer, but in the same proportion. So my ratio of A to B, my sides A to B, are the same as equal to my ratio of X to Y equal to my ratio R to S, which we can write as either with a semicolon, or we can write as fractions, which is how we're doing it with trig. So A over B is equal to X over Y is equal to R over S. Our ratio to our outer sides is the same because we've just zoomed in or out of our triangle. So the same thing as if we haven't compare different sides. If we have B to C is equal to Y to Z is equal to S to T. If we look, our sides are the same in the same positions on our triangles. So we're talking about those relationships are still the same. So B over C is equal to Y over Z is equal to S over T. And finally, if we compare C to A and Z to X and T to R, those are all the same. Those relationships are all the same. So C over A is equal to Z over X is equal to T over R. So those relationships, because we're comparing the same sides of our triangle, just depending on how much we've zoomed in or zoomed out, those ratios are all going to be the same. And that's the basic principle of how we move on from trig. All right, so we're going to look at the sine ratio first. This is on page 2 of your IL booklet in unit 3. So we have a triangle, a right angle triangle. For all of our ratios today, we need to have a right angle triangle. That is essential. So the hypotenuse we're going to define, or is defined as always the longest side, which is across from the right angle. Doesn't matter how your triangle is oriented, your hypotenuse is always across from your right angle, and it's always the longest side in your triangle. I label it as HYP, hype. I still call it hypotenuse, but I'm lazy, so I just write HYP. You could just write H if that works for you, as long as you know what you're talking about. Then we need to know what the reference angle is. And the reference angle is the important angle in the situation. So it needs to be defined in your question, either just on your triangle or in the question in your situation. That is your reference angle is really important. It's also key to know that your reference angle is never, ever the right angle. It has to be one of the other two angles. In this case, I've labeled the reference angle as A on my triangles. And so that's just the angle that we're talking about. So now the opposite side is always across opposite the reference angle. And this is why it's really key to know which your reference angle is because your opposite can change depending on if your reference angle changes. So our reference angle is A. So our opposite is a side across from our reference angle. So I label that as OPP. You could label it as opposite. You could label it as O, whatever works for you. So for the sine ratio, this is equal to, so sine A, which is spelled S-I-N, we use a short form, but I say sine, you could say sin, that's fine, is the ratio of the length of the side opposite angle A divided by the length of the hypotenuse side. So it doesn't matter how if we zoom in or zoom out of this triangle, it's always, that ratio is always going to be the same for every angle of A. That amount is always going to be the same. So in short form, we write sine A equals opposite over hypotenuse. Or if I'm writing out in a question, I would just put sine A equals op over hype, OPP over HYP, to help me remember that the sine is always the ratio of the opposite side divided by the hypotenuse side. Many folks use the shorthand SOHCAHTOA. So that is in your IL booklet, and you may have heard it in other places. It's not something that ever helped me, so I didn't usually memorize it. I remember as sine equals opposite over hypotenuse. That's what I used. But if saying saw as in SOH, sine equals opposite over hypotenuse, if that's helpful for you, feel free to use it. I'm a terrible speller, so that isn't something that's helpful for me. I just remember that sine equals opposite over hypotenuse. Okay, so let's look at a question and see how that actually is useful or how we apply that situation. So how to find the side length. This is on page 4 of your IL book. So for this example, we have solve for x, and we have a triangle that has a right angle. It has an angle P that is equal to 17 degrees, a side length that is 13.2 centimeters, and a side length labeled as x that's across from our angle P. So we look at our reference angle, which is P. That's the only question. That's the only angle that we have any indication about. So that's our reference angle. So the side that is opposite our reference angle is our X side. So I label that as OPP. Then I look and I say, okay, well, the side that is opposite is across from our hypotenuse. Sorry, across from our right angle is our hypotenuse. So I label that as H by P. So then I say, okay, I have the opposite and the hypotenuse are the two sides that I have information about. Either I have variable, that's what I'm looking for, or I have a number. So that means I'm using sine. So I say sine P is equal to op over hyp, opposite over hypotenuse. So then I input my values. I have sine 17 degrees. That's what my value is. My angle is 17 degrees is equal to x over 13.2. So then in order to isolate for x, that's what I'm trying to solve for. So I multiply both sides by 13.2 so that I can cancel off and isolate for x by itself. So then I have 13.2 times sine 17 equals x. So now you need to find your calculator and look for your button on your calculator. That is your sine button. And it is just says SIN, sin is the short form. And it should just be on your scientific calculator. So you just have a button that says sin. That's how it works. So then if you are going to calculate this, we'll look at, I've got a calculator, a Desmos calculator here for us to practice with. So we do 13.2 times sine 17. And that equals 3.86. Your calculator, you need to figure out if you put sine in and then your degrees, or if you put in your angle, your degrees first and then press sine. Each calculator is different. That's how you do it on calculator. Oh, I forgot to say, if you do your sine first before calculating it all, if you're going to do it in steps and you do sine 17 first, you want to write down to at least 4 decimal points. And then you times it. So if you're going to do 13.2 times 0.29237, so that equals x equals 3.9 centimeters. I do round it to 1 decimal place here because in the question is rounded to 1 decimal place. So I match what the question is saying. And that's how you solve for x, how you solve for a side length with sine. Your calculator must be in degrees. If your calculator does not say DEG at the top, degrees, you're going to get the wrong answer. There's multiple ways that you can do trigonometry in different units. Your calculator has the ability to do that. Your calculator has to be in degrees in order to do what we are doing. This circle degree symbol reminds us that it has to be in degrees. If your calculator says rad or grad, RAD or GRAD, you need to press the button that says DRG for degrees, radians, and gradients until it says degree, DEG. If you're having issues with that, let me know and we can find that where that button is on your calculator. It is essential, again, that your calculator is in degrees. You can do all the work perfectly well and get the wrong answer if you're trusting your calculator and your number is not coming out in degrees. So that's really important. Okay, so let's do another question. How to solve for the side length. So question 2, we're going to solve for y. We have a triangle with a reference angle of T, which is 64 degrees. Then the side length across from it is 58.1 centimeters. And then we have another side length that is labeled Y, and it's a right angle triangle. So in this case, we look and we say, okay, first step is to label our triangle. So we look across from the reference angle is our opposite. We label it opposite. Across from our right angle is our hypotenuse. So we label our hypotenuse. So in this case, we don't know what our hypotenuse is. Our hypotenuse is our variable y. We are still using sine because we know our opposite and we're solving for our hypotenuse. So that information tells us about that ratio is sine. So sine t equals opposite over hypotenuse. So sine 64 equals 58.1 divided by y. Multiply both sides by y in order to isolate for y. Right now it's in the denominator. We don't want it there. So we're going to multiply both sides by y so that we can cancel off y and we end up with y sine 64 equals 58.1. We're going to have to do another step because y still isn't isolated. So we're going to isolate for y by dividing both sides by sine 64. So this method has an extra step than the last when we're solving for just the opposite side. We didn't have to do this extra step, but because we're solving for something in the denominator that we're dividing by, we have to do this extra step so that we have y equal something opposed to 1 over y. This is something that people can make a mistake about lots. So y sine 64 divided by sine 64, that sine 64 cancel out. So we end up with y equals 58.1 divided by sine 64. And that equals y equals 64.4 centimeters. Again, same rules apply. Use your sign button on your calculator. It has to be in degrees. All right, so if you want to pause the video and do some support questions on page 4, questions 1 through 4, what we just did will help you solve for the sides using the sine. Again, we are solving for unknown angles in our next lesson, so wait for that. That will happen tomorrow. We're going to move on to the other trig ratios and then come back to solving angles tomorrow. All right, cosine ratio we're going to look at now. This is on page 7 in your IL book. So we on page 7. So again, looking at right angle triangles. Hypotenuse is still always the longest side in which is across from your right angle. That has not changed. That's definition is still the same. Okay, hypotenuse. Our reference angle is still the most important angle in our situation and it's still never the right angle, but we still need to know what a reference angle is for this. Now we have a new piece of information. It's called the adjacent side, and it's always next to or adjacent the reference angle. So here in my diagram, you can see that the adjacent is next to our reference angle A. So cosine A, or cos, C-O-S is how the short form, but I still say cosine A, is equal to the length of the side adjacent your reference angle A divided by the length of the hypotenuse side. So cosine A is equal to adjacent over hypotenuse. The short form how we can write that is cos A equals A dj is what I write for my adjacent. Or you could just write A sometimes, but that can get confusing in terms of your side length or your variable. So I write ADJ divided by HYP, cos equals adjacent over hypotenuse. Again, if you want to use the SOHCAHTOA tool, this is the CA, the CAH. So C for cos, A for adjacent, H for hypotenuse. Cos is adjacent divided by hypotenuse. All right, so let's look at how we find a side length with this information. This is on page 8 of your IL book. So solving for K, we have a right angle triangle with a reference angle of Q, which is 53 degrees, one side length K, and one side length 72.8 millimeters. So first, looking at reference angle and labeling our sides, we see that our side length K is our adjacent side to our reference angle. And our 72.8 is our hypotenuse. It's across from our right angle. So we have adjacent and hypotenuse. So that means that we have cosine Q equals adjacent divided by hypotenuse. That's how we're going to be able to find out what K is. So we substitute in our values. Cos 53 degrees equals K divided by 72.8. Multiply both sides by 72.8 so that we cancel them off and we end up with isolating for K. So we have 72.8 times cosine 53 equals K. Now our calculator button for cosine is a button on your calculator that just says COS, cos, or cos, sometimes people say it. And so that hopefully it should be right next to your sine button. So again, if you are going to do the calculation first and write it down, so we'd have 72.8 times 0.6013. Again, write the ratio out to 4 decimal places at least. Otherwise, you're going to get a wrong answer because you're rounding too quickly. So that equals K. So then K equals 43.8 millimeters. And there we go. Let's, again, I'm reiterating these parts because they're super important. Your calculator must be in degrees. So if your calculator is not, press, if it says rad or grad, press the DRG button until it says degrees. Super, super important. Okay, let's look at another question of solving for the side length. So we're solving for Z. We have a triangle with a reference angle of W, which is 40 degrees, a side length Z, and a side length 29.4 centimeters. So we label our triangle and we say, okay, we look at our reference angle and we say what's next to it is the adjacent. So that's the 29.4 centimeters. And then what the side that is opposite is across from the hypotenuse. Sorry, the right angle is the hypotenuse. Your adjacent and your hypotenuse, you could say, well, your hypotenuse is adjacent to your reference angle, because it is next to it. Your reference angle is between your hypotenuse and your adjacent, but your hypotenuse is always across from your right angle. So that's how you're defining it. Remember that. So because we have adjacent and hypotenuse, we're doing cosine of W equals adjacent divided by hypotenuse. So cos 40 equals 29.4 divided by Z. Again, you can see that our Z, our variable, is in our denominator. So we're gonna have to do a few more steps. So we multiply both sides by Z in order to isolate for Z, in order to get Z in our top so that it's not 1 over something. So the Z's cancel off. And we have Z cos of 40 equals 29.4. This is algebra. If you're struggling with algebra, then let's do some practice on that. But that's the tool that we're using that hopefully you're comfortable with. So then we're dividing both sides by cosine 40 in order to isolate for Z. And we get Z equals 29.4 divided by cos 40, which is equal to 38.4 centimeters. We just use your calculators to do that. Use making sure it's in degrees. Great. So now again, you can pause the video and do the support questions on page 9. Questions 8 to 11 are the ones about cosine. That will help you. Again, we are not solving for the unknown angles, which are part of your support questions, but we're doing that in our next lesson. All right, our third and final ratio is the tangent ratio. So this is on page 12 of your IL book. We still have the same triangles with right angles. Our reference angle is still the important angle in the situation, and it is not the right angle. So we have reference angle A. Now we're going to look, okay, our opposite is still the side that is across, is opposite the reference angle. Now this time we're looking at the adjacent and the opposite. So now the adjacent is still next to adjacent to the reference angle. So tan is equal to the length of the opposite angle, the side opposite angle A, divided by the length of the side adjacent angle A. So tan A is equal to opposite over adjacent. So my short form that I would use would be tan A equals OPP over ADJ, opposite over adjacent. That's how I remember it. This is your TOA in the SOHCAHTOA phrase. T for tan, O for opposite, A for adjacent. So tan equals opposite over adjacent. So this is just the third ratio of comparing of our sides. All right, so let's figure out how to solve for a side length yet again. This is on page 13. You can assume that we're going to use tan this time. So solve for G in a triangle, we have a triangle with a reference angle F of 74 degrees, and then a side length of G and a side length of 17.3 millimeters. So across from our reference angle is our opposite, so that's our side G. Adjacent to our reference angle is our 17.3 millimeters, so that's our adjacent. In this case, we don't have any information about our hypotenuse. We don't need it. So because we have our opposite and our adjacent, we're doing tan F equals opposite over adjacent. So we substitute in the information that we know and we're looking for. Tan 74 degrees equals G over 17.3. So solving for G, we want to isolate it. So we multiply both sides by 17.3. So 17.3 cancels off on the side with a G, and we get 17.3 times tan 74 equals G. Your calculator button is tangent, is TAN, tan on your calculator, and it should be right next to your cosine button. So for tan, if we do tan 74, we get 3.4874. So we do 17.3 times 3.4874. Again, make sure you have at least 4 decimal places, equals G. So G equals 60.3 millimeters. You can do the step of just pressing your calculator buttons and not writing it down, that's fine. But if you want to write down, make sure that you do at least 4 decimal places. As always, there must be in degrees, and to use the DRG button to get it in degrees if it isn't. So always something to really make sure that you're checking for every time you're turning your calculator on. Once it's in degrees, it should stay in degrees unless you press the button. But it's easy to get the button pressed and to no longer be in degrees. Okay, so let's do another question. So I've solved for D. So we have triangle, right angle triangle with reference angle J, which is 20 degrees. And we have a side length of D and a side length of 6 centimeters. So our side across from our reference angle is our opposite, and that's our 6 centimeters side. And then our side adjacent to our reference angle is our side D. So because we know our opposite and we're looking for our adjacent, we're using tan. So tan J equals opposite over adjacent. So tan 20 degrees equals 6 over D. So isolating for D, so we're going to multiply both sides by D so that it's no longer being in the denominator, so we're not dividing by D. So we get tan D, or sorry, D tan 20 equals 6. Divide both sides by tan 20 in order to cancel off the tan 20 so that we have D equals 6 divided by tan 20. So therefore D equals 16.5 centimeters. As you can see, this is all very, very similar. It's just a matter of knowing which ratio you're using. And then basically the algebra is the same. You're just isolating for your variable. And so then you're multiplying, dividing, depending on how you're isolating for your variable. So you're using algebra. All right, so again, if you'd like to pause the video and do some practice questions on page 14 of your IL book, the questions 15 through 18, you now have the tools to do. Always, we're solving for the unknown angles in our next lesson. So this is kind of the trickiest part, is which ratio do I use? Do I use sine? Do I use cosine? Do I use tan? How do I know? So we're going to go through the steps of figuring out how you decide. So the ratio is decided based on the information in the question. So you have to look at your question and figure out what you know and what you don't know. So step 1 is to confirm that it's a right angle triangle. If it's not a right angle triangle, we can't use any of these ratios. It's not true then. So here in our example, we have a triangle. Yes, it's got that symbol. It's a right angle triangle. Okay. So we can go into step 2. So let's label the sides of your triangle. It's always best to label your sides of a triangle. And I like to label all 3 sides of your triangle so that you see what's all going on, so you don't make a mistake, hopefully. And then you figure out what you know and what you don't know. So labeling our sides, first we have to figure out which one's our reference angle. In our example, our reference angle here is B. It's the one that we have information about. It's 36. It's got our little symbol that's showing us that it's an angle. our question has to indicate in some way. Either the question says that you're solving for angle B, or because angle B is defined as this, or it's in your diagram, but in some way your question has to tell you what your reference angle is. Even if you don't know what the angle is, like we're going to do tomorrow, they still have to tell you which angle you're looking for. So that is a reference angle. So then we use that to know, okay, our opposite is our side that's 48 in this question. Our opposite is opposite our reference angle. Our adjacent is our side that's n in this question. That's adjacent, it's beside our reference angle. And then our hypotenuse is our side that's across from our reference angle. Sorry, across from our right angle. My bad. It's hard to say the things. That's why it's really important to be watching the video so that you see the animations as well as hearing me float my way through. So that's why it's super, super important. It's really easy to just mix things up. So it's important to label and then you can come back. It also means that if you label your triangle and you're constantly labeling it incorrect, then I know that you're having an issue with a concept. So then I can help you with that. Or you just once in a while make a mistake, then I know that it was just a slip, that it was just a mistake. And that isn't a big of a deal because you just made a mistake. That happens, opposed to having conceptual error. This is why showing your work is super important. So we've labeled our triangle. Now in step 3, we need to identify what information we know and what information we're solving for. So here we say, okay, n is our adjacent, so that's what we're looking for. Our opposite is 48, and our reference angle is 36 degrees. So we either know our reference angle, our opposite side, we know those, and n is our adjacent, that's what we're looking for. So we then can, once we've identified that information, that's what we're looking for and that's what we're solving for, we then choose our ratio. So we say, okay, our ratios are sine B equals opposite over hypotenuse, cos B equals adjacent over hypotenuse, and tan equals opposite over adjacent. Well, we don't have our hypotenuse, right? That information, we're not looking for it, and we don't have that information and we don't have a value for it. So that means that we can't use sine or cosine because we need something about our hypotenuse. So in this example, our ratio is going to be tan B equals opposite over adjacent because we know our opposite and we're solving for our adjacent and we have our reference angle. And so that's how we choose which one. It takes some practice, but hopefully following these steps means that you're able to figure out which ratio is going to be useful for you. All right, that's a lot of information. Let's consolidate and hopefully we have some time to do some practice questions. So we have sine, cosine, and tangent are our ratios. So labeling the right angle triangle is essential. Labeling your opposite adjacent hypotenuse according to your reference angle is so important. Then we can use SOHCAHTOA, or we can remember that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. For this little period of time, you're going to get really, those are going to drill into your head, hopefully. Then we can solve for the unknown side using our algebra. So making sure that we're rearranging properly. If we're starting with algebra, let me know. And our calculator must be in degrees. Super, super important. Because then all of your work can be wrong, even though you're doing it right, but you're giving the wrong answer if it's not in degrees. So for success criteria, 1, hopefully now you can label your opposite adjacent as well as the hypotenuse side in your triangles. And 2, you can side for unknown sides using our trig ratios. All right, so let's do a few questions before our time is up. All right, question 1, in each triangle, name the side. So part A, we're looking for adjacent, the side adjacent angle R. So in yours, you're not, I mean, maybe you're writing in your booklet and you're sending your booklet to me, and that's fine. Or I would suggest drawing out your triangle. It does not need to be perfect. Label your right angle, label your vertices, put the letters on so that I know what's going on, but it does not need to be perfect. You don't need to use a ruler. It's okay if your sides aren't straight. It's okay if your right angle isn't perfectly right angle, but if you have the symbol, I know that's the one you're talking about. It doesn't have to be the exact same size, but having a triangle can really help. So we're naming the side of the that is adjacent to our right angle. So I'm going, our angle R. So this side is our adjacent. So there's different ways you could do it. You could draw your triangle and then just label it adjacent, and then I would know that you know which the adjacent is. You could also label it's in practice, this is side Q. So you could say that it's side Q. So it's a little q, could be one way that you could do it. Or you could also say that it is side PR. So you write capital P, capital R, and you draw a line above it. And that's telling me that's another notation that we used that says that that's that side. Any of those three ways would be totally fine. You just need to make sure that I know that you know which side is adjacent to angle R. Okay, so now let's look at part B. So we're looking for the hypotenuse. Well, our hypotenuse is the one across from our right angle. So again, you could draw your triangle and you could label it hypotenuse. Here, because what's across from it is an H, so you could also call it a little h, or you could call it side KJ, capital K, capital J, with a line on top of it. I would accept any of those three answers. Yep. Then we need to find C, the side opposite angle M. So I'm going to mark where angle M is. That's my reference angle. And say, okay, well, this side is opposite. So I could draw my triangle and label it opposite, OPP. I could say, okay, well, it's the one opposite M. So it's going to be a little m. It's also what it's called. Or it's the side, we could say it's LN, because it's the side between our corners L and N, and we draw a line over it. And those are the three different ways you could label the side. All right, so question 2, calculate the sine A, cosine A, and tan of A. So I have a triangle with my reference angle A. I don't know what my angle is, but in this question, we're just asking to calculate the sine. We're not trying to find the angle. We're just trying to say what the ratio is. So sine, so how I would do this is I'd say, okay, right, I know it's a right angle triangle. I found my reference angle, and now I need to label my sides, right? So the side across is my opposite. The side adjacent next to it is my adjacent, and the side across from my right angle is my hypotenuse. Doesn't matter which order you label those in, whatever makes sense to you, but those are where they need to go. So sine is equal to opposite over adjacent. So that is equal to my opposite side is 5.6. And my adjacent side is 8.1. So that is, if we do that on a calculator, we have 5.6 divided by 8.1 is equal to 0.6914. 0.6914. And that's what this question is asking for. It's saying to calculate just the sine. You can either leave it as the fraction, but it makes more sense to divide it out and have that rounded out. You're not trying to find for the angle. So then to find the cos of A, so our cos is equal to adjacent over hypotenuse. So that is equal to, oh, I totally did that wrong, didn't I? Is my sine equal to the opposite over adjacent? No. Catch me. I made a mistake. So that, what is my sine? What is opposite over adjacent? That is tan. I did the tan instead of the sine. See, it's totally easy to make mistakes. So that is tan. I calculated before. Okay, so let's go back to cosine. Cos is adjacent over hypotenuse. So my adjacent side, even though I labeled everything right, I just did it wrong. And then hypotenuse is 9.8. So again, with your calculator, 8.1 divided by 9.8 is equal to 0.8265. So cos A is equal to 0.8265. Okay, and let's try to do the sine again. This time, let's do it right. So sine is equal to opposite over hypotenuse. Oops, teachers make mistakes too. It's how we learn. It's all good. Okay, so sine is opposite over hypotenuse. So opposite is 5.6, hypotenuse is 9.8. So then if we divide those, we have 5.6 divided by 9.8 equals 0.5714. So sine A is equal to 0.5714. And that's how you answer that kind of question. All right, let's keep going. All right, question 3, calculate, and then we just have A sine 29. So we just need to calculate this. We just do this on our calculator. We don't have any other tools to do it. There is a table you can look up, but that is like old school. So let's just use our calculator. So we are using our calculator. I'm just going to move it over so that we can see. So how we do that on our calculator, as we see here on my calculator, I have sine. My calculator, I press sine first, and then I do 29 equals, and we see that it's 0.4848. So sine 29 is 0.4848. So for any triangle that's a right angle triangle that has an angle of 29 degrees, the reference angle, the ratio of its sides are always going to be 0.4848. All right, cosine of 48, how do we calculate that? So we go to our calculator and we press cosine 48, 84. I'm really doing great today. So cos of 84 is 0.1045. So 0.1045 is what that ratio equals. And C, tan of 55. So we press tan and 55, and that equals 1.4281. 1.4281. And that's how we calculate it if we're given the angle. And that's also, we're done with that question. All right, so let's calculate for X this question. So we are going to go to our 4 steps. So step 1, is it a right angle? Let's look. Yes, we have a triangle with a right angle. Great, so we're good to do these. Then we're going to label our sides. Well, here's our reference angle. It's 37 degrees. So across from that is our opposite. And then we're going to say, okay, adjacent, and next to it is our adjacent. And across from our right angle is our hypotenuse. So in this question for step 3, what information do we know or are we looking for? Well, we know we're looking for our opposite, our X, and we know our hypotenuse. So because we have opposite over hypotenuse, we know that we're going to use sine. So sine of 37 is equal to opposite over hypotenuse. This time we weren't given a letter. That's fine for our angle. So we're just going to say sine of 37 is equal to opposite is our X over hypotenuse, which is 29.5. On isolate for X. So I'm going to times both sides by 29.5. You can do brackets, you can do time symbol, whatever makes sense. You can also just write the number in front of sine. That's what it would mean. Do what works for you. So the 29.5 cancel off, so I'm just left with X. And then I'm just going to use my calculator, and I'm going to say 9.5. You need to remember to put your times, that you have to press your times operator in your calculator, though. You can't just write it, you can't just put it next to it. So 29.5 times sine 37 equals 17.75. So 17.8 is what we'd round that to. So X equals 17.8. And there we go. All right, we don't have time to do our word problem today, but I would strongly suggest when you have a word problem to draw a picture. Draw your picture. That is your best friend. Okay, so draw your picture so that you understand what's going on, and then interpret your question. Follow the same steps. Make sure you've answered the question that is being asked for. So we're going to continue this unit or this lesson tomorrow to look at the angles. But as always, you can contact me if you have any questions or have any issues. You can call, leave a message for me at the office, email me, Facebook me, and this will be up on YouTube later today. I hope you have a lovely day. Thanks for joining me. Miigwech.